Today we are going to be using the law of cosines to solve the triangle. Yesterday we did the law of sines and it's much easier. As you can see, the law of cosines formula is a little bit more complicated looking. So we are only going to use the law of cosines when you cannot use the law of sines, or mostly when the angles are not given but the sides are given. All right, let's look at the formula for a second. It looks kind of like the Pythagorean theorem, and then it's got some extra stuff in it. And that is the cosine part of it, obviously. But you have to pay attention to the capitalized letters and the lowercase letters. Remember, lowercase means the sides, and then uppercase means the angles. And so that will apply in the formula. So you have side, 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 and then only one angle in the entire formula. Okay, and that angle is very specific. Whatever angle goes here, the side must go here in the formula. And so that's the only thing you need to worry about in this formula is whatever angle is here, the side must be on the opposite side of the formula. Okay, that's important. All right, let's do an example. Notice if you try to use the law of sines in this problem, it won't quite work because you'd have to do sine of 25 over that, but then there's no other angle to do anything with. There's no angle to do anything with. So law of sines does not work in this problem. So we're going to try to go ahead and do the law of cosines. All right, and notice there's only one angle that's given. That's 25 degrees, and that will go into the A. That means this has to be the one that's directly across from it. So it'll be little y. All right, so that's the only important stuff. The angle and the side across from it have to be on opposite sides of the formula. All right, so let's go ahead and fill in our formula then. Notice that the y is here. The b doesn't matter. The b and the c don't matter. So I chose b to be 11 and c to be 14. And then fill in the rest of the formula. Minus 2 times b times c, and then cosine of the angle A. All right, at this point you have to be really careful using PEMDAS. Don't punch everything into your calculator because your calculator might not be smart enough to do PEMDAS. So go ahead and show a little bit of work. Do the 11 squared, do the 14 squared, and then these three, actually this whole thing, you can punch into your calculator all at once, and it gives you that amount. Be careful not to lose that minus sign. And then from there, you punch all of these into your calculator to get something like that. And then finally, don't forget, you do need to square root the answer to get the y. And there we have it. Turns out that y is equal to about 6.1524. We are going to go ahead and round to 4 decimal places. All right, so we've only solved for one thing in the problem, which is the missing side. let's go ahead and try to find the missing angle. There's two angles missing. There's the angle x and the angle y. Let's go ahead and just do one at a time. Let's do angle x first. There's the formula again. We're actually solving for angle x. So the angle goes here. In this case, the x is going to go there. So then which number has to go here? The 11, the 6.1524, or the 14? It has to be specific. It has to match the angle. It has to be the one that's directly across from it. So it has to be the 14. All right, so there it is. We have put in the 14. That means the 11 and the 6.1524 are the B's and the C's. Plug out all of that into there. And then, of course, that's what we're solving for. Again, don't try to punch everything into your calculator at once. You can do the 14 squared, then the 11 squared, then the 6.1524 squared. And even these three you can put in all together at once. Alright, so there's a 14 squared, there's 11 squared, there's a 6.1524 squared, and then all of that is the 135. At this point, be careful again with PEMDAS. You have to know your order of operations. We can combine these two together. We cannot combine that with them because the 135 is attached to the cosine, so do not combine that with that. That is no good. Just go ahead and combine these two together. That gives you that. Then at this point, we're going to bring over the 158 by subtracting it over. And that's what we get. And then finally, we get to deal with that number. Do not forget about the negative. It is very important. If you forget about the negative, everything is wrong. So divide by negative 135 to both sides. So when you divide to the other side, you get some tiny number that looks like this. And then at this point, to solve for x, you have to do something to the cosine. Hopefully you remember. To get rid of a cosine, you cosine inverse. Cosine inverse both sides. Alright, when you cosine inverse both sides, you should get about 105, 106 degrees. Okay, all of that work just to solve for angle x. And we're not done yet because we still have one more angle, angle z. Now, angle z, you have a few choices. You can set up the problem and do it all over again for angle z, or if you want to take a shortcut, you can use the triangle sum theorem. The 25 and the 105 must add to the z to get 180 degrees. So if you want to do that shortcut, you can. You just have to be careful that this answer was right. If this answer is right, then this answer should be right. If this answer is wrong, and you use a shortcut, that answer is going to be wrong as well. Alright, so just be careful if you use a shortcut to make sure everything's correct. Otherwise, if you want, you can set up the whole problem again to find z. Let's do one last example for today. It's kind of like the last one, but if you notice, all three angles are missing, so no angles are given. All right. Again, when no angles are given, you cannot use the law of sines. You have to jump to the law of cosines. All right, so that's what we're going to do. There it is, the law of cosines. Let's decide what angle we want to solve for first. Usually we just go for x because that's what we're used to, so we can go ahead and do that. Remember, if x is what you're solving for, then a has to be directly across from it, just like that. Again, only if you're highly skilled at using your calculator, but if not, you have to show some work. Nine squared, 7 squared, 3 squared, and then all three of these together. All right, you can go ahead and combine these two. Remember, you cannot combine that because that belongs to the cosine. From there, subtract the 58, and then from here, divide the negative 42. Again, be careful, do not forget about the negative 42. And you should get something like that. And then again, to solve for x and to get rid of cosine, you have to do cosine inverse. Once you get the cosine inverse, we have our angle that goes in here. All right, and then I already jumped the gun, but I guess the next angle we're solving for is z. There it is, z. Again, if you're going to do z, then that number has to be the one that's across from z, which is 7. All right. And then the 9 and the 3 don't matter at this point. You can choose whatever to be the b and the c. Show a little bit of work. That squared, that squared, that squared, and then all three of these together make 54. You can only combine these two, not the 54. Subtract the 90 to both sides, and then divide by a negative 54. Be careful, that's a negative 54. And then we have this. To solve for z, you have to do cosine inverse. Once you do cosine inverse, we do get z to be about 40 degrees. That goes here. All right, so if you're 100% confident about that answer, and you're 100% confident about that answer, then you should use the triangle sum theorem to solve for that angle, which is about 16 degrees. If you're not confident, go ahead and set up the whole thing again to find y. And if you have time, you can set it up and check your answer. But if you did it all correctly, that should be the correct answer. All right, it is a lot of work, but that's all we have for today. Go ahead and try your homework. Thank you.